Hello everyone. We're starting a free open lecture in our Discord channel. All our lectures are held daily, without breaks. If you're a viewer and want to ask questions and get answers in an online format, then join our lectures. You can find the link to Discord in our Telegram channel. To find out the time of the lecture, join our Telegram channel and Discord. Board size n by m, start x1, y1, end x2, y2. Place walls to block path, board up to 10 or 9, points not adjacent, blocking possible. Minimum walls needed, 4 in example. Determine max walls for board size. So what we essentially need to do is place some walls, roughly speaking, in order to block some cells so that a person can't effectively get from x1, y1 to x2, y2. The board has each dimension up to 10 to the power of 9. And it's guaranteed that they are not adjacent, meaning they don't share a side, so they can't be next to each other. This means we can always block them. We need to find the minimum number of blocks we can place, but we want the minimum number, and that's what we want to figure out. So here, the answer is specifically 4, which is exactly the drawn test case in the first example, where 4 walls are placed. Now, let's approach this logically and easily. How many walls do we need at most? Our size goes up to 10 to the power of 9 for each dimension. Well, actually, that's already the answer, in essence. The number of walls is not quite. The number of walls equals the points you can reach the endpoint. Well, yes and no, because there can actually be fewer walls than the number of points from which you can reach the endpoint, but yes, that's close to it. What's the matter? In fact, we will never have a case where we need more than 4 walls. Why? It's very simple. Here we have some kind of our infinite huge board, which is vast and expansive, and it doesn't matter in this context. So we have some starting point on this board, which is the initial position, and an ending point, which is the final destination. Yes, we just surround this point from all 4 sides, creating a boundary, effectively isolating it, and it can't be reached due to this enclosure. But the only thing is that in the case I've drawn, 4 would be the wrong answer, as it does not fit the scenario. Why? Because we can actually do it in 3 if we block the player himself instead. Well, there, a little man, a player, I don't know. It's not so important. So yes, we'll just choose the more advantageous one, either we block this one or that one, and simply provide the answer. It's such a simple problem. It has nothing to do with graphs except for the tag for some reason. There are flows here, but they are unclear. Anyway, the task is just, well, it's very simple for test cases. We just read them in, insert them, and it will get better. 2 seconds, 256 megabytes, given the string s. Each of its characters is either 1, 2, or 3. We need to find the shortest continuous substring s in which each of the 3 characters appears at least once. So basically, we need to output the length of this substring. The number of input sets is up to 20,000, but the total length of all strings does not exceed 200,000. In our case, this is the only constraint that interests us overall. Well, for each set of test data that we input, this is one single number, the length of the shortest substring s that will contain characters of all 3 types. If there is no such substring, then we enter 0. So 7 is the number of test cases. But as I said, in this situation, it doesn't really interest us much because our complexity is limited here. Obviously, we can't do it in quadratic time because we won't have enough time. We need to choose something shorter, and our options are to use 2 pointers. That's the right approach. So in the first case, it's clear we have the correct answer. In the second case, there it is. In the third, we'll highlight it. In the fourth, we'll highlight it. In the fifth, it's not there because we don't have a 3. In the sixth one too. And in the seventh, there's a 4. So how are we going to do this with 2 pointers? One will move and the other. So how are we going to do this with 2 pointers? So one of us will move, the other. What will the other one do? It can move towards the first pointer or follow it. The first one always moves left to right. Where will the second move? Until all 3 characters are in the segment. The first one always moves from left to right, that's for sure. The second one will move in the same direction until we have all 3 characters in the segment. This is, well, overall. Yeah, by the way, this is also one of the solution options. Well, actually, it's pretty simple too. We'll move the second pointer from left to right as well. And what are we doing? We'll move from left to right, and we have a counter for 1s, 2s, and 3s. I created a map for this, but you could use anything. Just add 3 variables. We read it, put 1 in 1s, then in 2s, put 1, 2, 3, 4, add another 1 to 1s, making it 2, and 1 goes into 3s. It's clear we'll find it, but the length will be too large. As long as the value from the second pointer for one parameter is greater than 1, we'll move our left pointer to the right. It's clear we'll find it, but the length will be too large. And then, as long as the value from the second pointer for one of these parameters is greater than 1, we'll shift our left pointer gradually towards right side. So what exactly are we going to do? So both of us started from here initially together at first point, but eventually stopped here, and we start moving. We have a 2 here, so we'll subtract and move to the left. Next, from the 2, we clearly have 4 here, so we'll move. Well, we'll move right up to the last 2, and here we'll find 3, so we'll move right up to the last 2. And then there will be 3. Got 3, could stop, but complexity allows more, nothing less than. It's not that important. Our complexity allows us not to stop here, so we'll look for less after we find this. But naturally, we won't find anything less than 3, and the same will actually be true in all other cases. If we went through and found nothing, then it's clear we have 0. So how do we do this? The easiest way is to create an answer variable and set it to a large number, for example, something greater than 200,000, because that's the maximum length of the string. I just took int max to make it easier, and each and every time I got an answer, we carefully and thoroughly compared it, taking the answer and setting it to the minimum of the answer and our current and ongoing result or outcome. From the answer to the code of the current result, that's it. In conclusion, therefore, if at the end we had an answer equal to the maximum integer value, int max, then we enter 0. In other cases, as a result, we input the answer. There's probably nothing else really interesting here, just the code.
Want to become a great programmer? Subscribe to our Telegram channel.